Now, there are various techniques which can be employed while fine tuning LLMs. We won't go in depth for each technique, but it is good to know the possibilities so that these can be explored individually. First is full model fine tuning. Here, all the model parameters are updated based on the custom dataset. This technique is useful for complex specialized tasks, like if you are creating a medical chatbot. This will require a full model training for specific medical datasets. As you can imagine, this full model training will require large and varied datasets. This is extremely resource intensive as well, and it needs high compute resources to execute. So if we have these resource constraints, we can go for something called as low rank adaptation or LoRa. LoRa reduces the number of parameters to train. We do not update all the parameters as in full model training. This is done by injecting small trainable matrices into the original model. This is suitable when we do not have large resources and we only need quick updates. For example, a chatbot backend LLM needs to be updated for holiday schedule. There is minor loss in accuracy, but this is cheaper and much faster to train. Then there is another fine tuning technique called as adapter layers. Basically, addition of small layers between original layers of the model that learn new information while keeping original parameters intact. This can be utilized for domain specific adaptation like fine tuning for use of financial language. This is very easy to execute and manage, but of course, this will have very narrow task focus. These are various fine tuning techniques you can adapt. Based on your need, you can explore a particular technique in more detail and depth. Alright, now we want to discuss a very powerful strategy using fine tuning. The technique is to leverage high cost models like GPT-4 to generate very good data sets for your domain or purpose, and then use those data sets to train lower affordable models like GPT-3. This ensures you get best of both worlds. You get your own high performing models at a fraction of the cost. Let's see why this is possible. See, GPT-4 can provide more accurate, nuanced, and contextual responses, which can be used just one time to build great datasets. Now, GPT 3.5 is cheaper in production for every time use. So, fine tuning this GPT 3.5 on the dataset we obtained from GPT 4 makes GPT 3.5 perform at the same level of accuracy as GPT 4 for your specific task. And we are incurring much less cost as GPT 3.5 is much cheaper for everyday use. So you get a scalable strategy to balance expenditure and performance and accuracy. Do use this powerful technique of fine tuning lower models with data created and generated from higher models for your use cases.